Hello and welcome. I'm so excited to finally make this video. I've been dying to answer this question of how do alkaline water machines work, because they're really cool. Water comes in, one side is acid, one side is alkaline, but how do they do that? How do they do that? It's really cool. Well, I'm going to show you, and I'm not just going to show you. We're actually going to tear apart a $1,500 Kangen alkaline water machine and strip it down to its very soul to show you. So, how does it work? Let's get on with this. Well, I have one, and I had to go out to my shed and go find it. I haven't used it for a couple of years. By the way, I really like alkaline water machines. I think they're really cool. They're a little clunky because they sit on the counter and you got all these hoses and stuff. And I would still be using this one if it wasn't so hard to hook up on the kitchen sink. But I found something better now, so it doesn't really matter. So anyway, so here it is. It's a little bit dirty, but it's still fine. I took off the cover, so there's the filter. Once you take the filter out, then you get down into the goodies. So once you turn it around backwards and you take all the screws off, well, now finally we're inside of it. And there's really only three parts to an alkaline water machine. The electrical components inside, so it's all the circuits and the gizmos telling the electricity where to go. There's a pretty huge transformer, and transformers either step electricity up or they step it down. And in this case, it's stepping it up to a whole lot of volts. This thing weighed like 4 or 5 pounds. It was huge. But the real brains of the operation is this funny looking thing here. You see, the water flows through an alkaline water machine, and the circuits and the transformers are there to support this white looking thing. You see, as the water flows through, it goes past these plates. And on the plates, it's bombarding the water with an electrical charge, and on the other side, it's taking the electrons away. So how does that work? Well, that's like I say, that's the real guts of it. Here it is again. Interesting looking component. And on the back side, there's a big metal plate. Notice there's a ground wire going to it. Once I stripped all of the screws off of it, then there was another plate, and I couldn't get any further than this because there's this rivet right here. And if I'd pulled that off, I would have broken the plates and broken the machine. Didn't want to do it. So I pulled it back as far as I could, and you can see inside. It's a little hard to see, but it's the beginnings of those plates. Here's another picture. You can see it a little bit better. But that's the long and the short of how the thing works. In other words, water flows past. There's these plates, and it's like I say, it's bombarding it at a very certain frequency and a very certain voltage to charge the water. Okay, that's great. What does that mean to you or I? Well, water comes in and gets electrically charged. So what? So first we need to answer, how does a pH meter work? It's a very good question. You see, a pH meter, pH, of course, stands for parts or percentage hydrogen. So all it's looking for is hydrogen in a given level of water. If the hydrogen levels are very high, it reads it as acid. If hydrogen levels are very low, and in other words there's more oxygen now, it reads it as very alkaline. If I lost you, it's okay. We're going to get into that. This picture here is obviously it's a water. You have a big oxygen in the middle, and then you have two hydrogens. So you have two H's and an O, or H2O. Simple enough, right? If you get into exactly how all of that fits together, a large oxygen molecule has two spots right here at the top. In the world of chemistry, those are called valences. And if you ever see like a molecule that's all stuck together, it looks kind of random. They're not random at all, because every molecule has a valence, in other words, a spot where other molecules can fit to it. Each valence either has a positive electron or a negative electron, and that's what attracts or repels other things. It's actually pretty simple. So, for example, with oxygen, you have two valences, and both of them have a positive charge. So in the case of oxygen, it has two electrons to give away all the time. Well, hydrogens have a negative, and opposites attract. That's why water is stable, is because the two negatively charged hydrogens glom onto the oxygen. Everybody's happy. So you see here the big hydrogen. I made it nice and big, and here's the negative charge. Sometimes hydrogens can have a positive charge, but for the sake of this conversation, for the sake of everything, they're almost always negative. So in other words, hydrogen literally wants to steal your electricity. It wants to steal your electrons. It's trying to fill that void. And it gloms onto oxygen. That's why acid things are so bad for you, is because they literally steal your energy and they literally steal your oxygen in a very real way. So if there's any chemists watching this, you're probably squirming in your seats because this is not accurate, but it's just for illustration purposes. These are big. This is water. These are water molecules floating around, and I drew a few extra hydrogens. So my point is if you put a pH meter in this water, it would read all those extra hydrogens and go, oh, this is acid. This is acid water. And on the flip side, with this one, I took out the hydrogens and I put extra oxygens. Now you can't have just a plain oxygen floating around, it's unstable. But you get it for the point of illustration, the pH meter would say, oh, this is very alkaline water. In other words, it's reading these stable waters, but it's also reading extra oxygens, and there's no extra hydrogens. It's alkaline. Hey, that's great. And of course, if you read it with what's called a millivolt meter or a millivolt meter, it would be reading the electrical charge, and it would be picking up all of these extra electrons, and it would give it a tremendously high electrical charge. It would say, in other words, this has plenty of electrons to give over to you. So here's how the alkaline water machines work. Are you ready? This is the cool part. This is really cool. Here's my incredibly well-drawn piece of dirt floating in water. Yes, I drew this on the computer. I wanted to illustrate just a piece of dirt. In other words, in water, there's things. In other words, there's tiny little pieces of copper and pieces of calcium and pieces, just tiny little particles. Even if it's been well filtered, there's still stuff in there. Unless the exception is, of course, distilled water. But for the most part, there's always at least something in water. That's what this is. So this is a little, let's just say it's a piece of copper or a piece of calcium, like I said, floating. It's microscopic, but it's floating in the water. It's stable. It's happy. It's not doing anything. But what if you ran it through a very specifically designed channel of these metal plates with a certain frequency and certain electrons? Like, for example, what if you just stripped all the electrons off of that piece of calcium that's floating by? Well, it would look something like this. In other words, you stole all of its electrons, and now it has all these negatives all the way around it. Well, now, what if this guy was in the middle of a bunch of H2O? Well, pretty simple. The bond, this negative bond, would be attracting these positive bonds. It would literally knock the hydrogens off of the H2O, and it would glom up all of the oxygens, setting these hydrogens free. Does that make sense? It's cool, right? In other words, it literally, it's such a strong charge, it broke an H2O and stole the oxygen. Now, when you put a pH meter in this water, what's it going to read? It can't read these oxygens, they're bound. All it can read are all these hydrogens floating around. So in this case, this is very, very acid water. And the opposite is totally true too. Because if you forced electrons on this big piece of dirt, in other words, all the positives, all the oxygens would repel and it would bind all of the hydrogen. And what happens when you read water that has a bunch of oxygens? It's alkaline, right? Because there's all these alkalines. So your pH meter goes in there, wow, this is incredibly alkaline water. Not necessarily. Because when the electrons go back to normal, which is best case scenario 2 days, if you leave this water like in a clear bottle in the sunshine, the rays of sun will totally neutralize it within just a few hours. If you put it in like a steel bottle, it'll last a couple days because there's no outside interference from the sunshine. So the H2O goes back to normal. Now, let me ask you a question. If you have water in a sealed container, it's all about hydrogen and it's about oxygen, but it's a sealed container. How could you have something that's very acid or very alkaline, and yet the numbers of hydrogens and oxygens go back to normal when they can't get through the sides? You can't. In other words, that's like a magic trick. It doesn't happen because they have to come from somewhere. In other words, if your pH meter, let's say it reads it as alkaline water, so there's extra oxygen, and then it falls back to normal, where did those hydrogens come from? They didn't go through the side of the bottle. The fact is they were never gone. They were always there. They were glommed onto that piece of dirt, that piece of calcium or whatever it was that was floating in the water. So this is not true alkaline or acid water. It's not. It's almost like a hat trick that was done with this pH meter, because the pH meter is telling you something, but it's true at the moment, but it's not true. It's not true because you didn't remove the hydrogen, or you didn't remove the oxygen from this water. So you do get, in the case of alkaline water, you do get free electrons. In other words, those electrons that fire your body, you do get them. And that's why those Kangen water machines and things like that, they give you that extra little woohoo, that little boost. And you feel good because you're literally getting free energy, which is really, really cool. So, but you are not removing hydrogen or acidity from the body. Do not be fooled. You're not removing acidity. If you were removing acidity, what these machines do would be even more amazing. In other words, you could have a person, let's say, with a long-term bacterial infection that was in sepsis, and you could turn them around just like that. In other words, you would literally remove the hydrogen and get rid of it. With alkaline or Kangen water machines or alkaline water machines, you feel better. There's a little extra pep to your step, but you cannot get out of sepsis with one of these machines. You can't get out of, like, for example, diabetics. Diabetics have extremely high levels of lactic acid because of the way diabetes happens. There's a certain way that the blood sugar, the body burns fats, and then what happens is it actually creates a hydrogen. After that, that binds with lactate. Lactate is the energy in our muscles that we use, and it becomes lactic acid. So diabetics, they're constantly trying to get rid of this lactic acid. After a while, their body is overwhelmed. Acid levels, in other words, the hydrogens, there's more hydrogens in their blood than oxygens. Their oxygen level goes down, circulation decreases, which I don't really consider bad circulation. I consider more lack of oxygen in the blood. You would be able to just drink alkaline water and then it would go back to normal because you would bind those hydrogens. Diabetics feel better with alkaline water machines, but it doesn't remove the hydrogen. That's what I'm saying. Don't be fooled. So, what is Alkalize energy? Alkalize energy is quite a bit different, because Alkalize energy, we start with the same water, but in the case of Alkalize energy, we still have these two positive electrons, but what we've done is we figured out how to remove simply one hydrogen. And it's beautiful. The name of this molecule is called hydroxide. And to tell you the truth, in a lot of ways, Alkalize energy is also unstable. Now, let me explain that. You see, we go to, first off, it's double patented process of how we're able to remove one hydrogen and create hydroxide. We have this free electron, in other words, energy for your body, and that's why you feel better, but there's an extra kick with Alkalize energy. What is that? The extra kick is the fact that you literally have extra oxygen. In other words, because it's removing, bam, it's glomming onto a hydrogen. In other words, if you have extra acidity in your body, acidity is hydrogen, it gloms onto that, turns back into water, and you get rid of it. Alkalize energy is by far, the highest alkaline water on the market. And when I say it's unstable, it's actually to the advantage, because hydroxide in a bottle, it's sealed. So you can put that bottle in sunshine, you can freeze it, you can do whatever you want to it, but when you drink it, it's unstable in the sense that it's looking to be filled. In other words, nature doesn't like a void. Nature doesn't like to be unbalanced. It wants to find hydrogen. So when you drink it, oxygen levels go up just because you've removed hydrogen, and you get that free electron, which is the little little boost to your step. That's why it's so absolutely amazing. So that's what we have. That's Alkalize energy, and that's also how alkaline water machines work. They both are pretty amazing new technology. Hope you enjoy both. We'll talk to you soon.